Hey guys, this talk's all about testing applications in a Regtest environment and a dev tool that can make that easier on you. I go by the name OstiCon online, and you can find me on Twitter, Slack or Telegram. I'm involved with the ElectrumSV wallet and the co-maintainer of the ElectrumSV SDK, which is the dev tool that I'd like to show you, and also the maintainer of BSV, which is a Bitcoin Python library. So as far as the pros and cons of the public test networks, so that being a testnet and scaling testnet, the main advantages of those are that they're very easy to get started with, and compared with a Regtest, you don't need to run your own local instances of third-party services. And the other aspect is that it's a more realistic preparation for a production environment, because you do have the network latency effects, and depending on what you're doing, that might have quite a significant impact on the user experience. So there's that, and the disadvantages are mostly around a lack of control. So you don't control when a new block's mined. You have no control over when a reorg happens, and you certainly can't hit the reset button and replay the reorg again. And so if you've fixed a bug due to mishandling of a reorg, there's no real easy way to verify that you've resolved that issue. And so that's in contrast with the Regtest, where, for those who don't know, Regtest is basically a private local Bitcoin network, and the difficulty adjustment algorithm is such that you can mine blocks on demand. So that's the main advantage, actually, that you can mine blocks on demand, because nobody wants to wait 10 minutes for a block. And if you know what you're doing, you can also trigger reorgs on demand. So what you have is you can handcraft raw blocks with the transactions of your choosing, with the keys of your choosing, and you can decide, at what block hash the reorg happens, and you can hit the reset button, so to speak, and replay the same event again. And so that lends itself very nicely to acceptance testing, and you can, if you're willing to do the work, you can add that to your CI/CD pipeline. And the other aspect is for benchmarking. Mainnet, if you're doing high throughput testing, mainnet is too expensive. Test network is not really meant for high volumes. It's designed for servers running on weak hardware, and the scaling testnet can be a bit intimidating if you're still prototyping. So there's that, and there's also the aspect that Regtest removes network latency from the equation, and depending on what you're doing, that may or may not be an advantage. But personally, when I'm still prototyping something, I want to get my own house in order first before I worry about dealing with connectivity issues or third-party service provider problems. I just want to get my core business logic sorted first. And so now we're going to start looking at the SDK. I don't want to dwell on the installation. We have comprehensive documentation on our website, so you can go to the Read the Docs website here, and it's a Python application, and it's hosted on the Python package index. So most of the installation process is all automated, and you can check that out if you're interested. And so the main use case with the SDK is obviously running a node and topping up an address. And so the SDK works cross-platform. And so although the official binaries for the node software run on Linux, there are no official binaries for Windows and Mac. So what Roger and I have done is we've compiled native binaries for Windows and Mac, unofficial binaries, and only for use in a Regtest scenario. But that's what we've done. So as far as I know, this is the easiest way to set up a Regtest node on Windows or Mac. And I guess depending on how comfortable you are with things like Docker. So if I open up a terminal, so crash course on the SDK. So if we bring up the help menu, the main commands are start, stop, reset, and node. Node giving you RPC access to the running node. And if you've got multiple nodes running, you can specify which node you want to talk to. Start command. So these are the built-in components that you can launch. And so if we want to start a node, by default, it will launch a terminal window with the logging output there. Stop the node like this. And then we can also, so if you're running on a remote server, you're actually going to launch the node in the background. So if you're using this for CI/CD testing, you'll actually have to use the background flag because it won't handle you launching a new terminal window in that setting. So like that, start background node, and then the logging output is directed to a deterministic directory. So there's the Electrum SV SDK directory, and there's a logging directory with each component, and so you just come in here, and so node 1 is like a unique identifier for this node, and we can have multiple instances, multiple nodes with their own unique identifiers. And so you come in here and you'll be able to see the logging for the node that's running in the background. Okay, so every component type has its logging captured and redirected in this way. So we've got a node running, and then we can start connect. Console windows, and okay, so we've got a clean slate, an empty wallet, and we want to top it up. One thing you'll find is that on Regtest, if you have a fresh node, you do need to generate some blocks. You need to generate enough so that you actually have matured coins. You need to generate at least 100 blocks, and with one extra to start having enough matured coins. So I'll generate 200 blocks just to be safe. And 10 bitcoins. And there's our transaction. So it's unconfirmed at the moment, so we can generate another block. In a moment, that will show confirmation. So the other use case is running a merchant API instance locally. And so if I flick over to the terminal window, so we already have a node running. So now if we start merchant API, we get this logging output, and it's configured to run on localhost 5051. And if we come over to Postman, and so when you first set this up, you'll have to add the node. So you'll have this in the body of the request. And by default, the node is configured to run listing on port 18332 for RPC requests. And the RPC user, RPC password, by default for the SDK node instance, it's always RPC user and RPC password. So this is what you send, and I've already run this command, so it's already been added previously, and now we can get a fee quote as an example. And if we wanted to look up the transaction that we sent earlier, can come into get transaction, and then we need the hash from the wallet. So we would come in here, and there's the JSON response. So just to finish talking about the merchant API, so I think as block sizes increase, it's going to become more of a standard service that you run alongside the node. And so if you want to do end-to-end CI/CD acceptance testing, you will have to run the merchant API, a local instance of the merchant API. And what I found was that there are a few steps involved in setting up the merchant API at the moment. So you need a Docker installation, you need a node that's configured with all of the ZMQ endpoints, and you need a self-signed SSL certificate. Probably the last one, the SSL certificate, is the most annoying one. But that may be removed as a requirement in a later release. So, but basically with Electrum SV SDK, we've tried to take over as much of those responsibilities as possible. So the node comes pre-configured with all of the ZMQ endpoints. You don't need to worry about that. And we've removed the requirement for having a Docker installation. Basically, we've created unofficial binaries for each platform, and are standalone with all of the dependencies. So as far as that goes, it should work right out the box. But you still do need to do the SSL self-signed certificate, but that's all documented if you're interested. So the other main use case is obviously simulating a reorg. And so I'd like to run through an example where I basically reorg a transaction from block height 201 up to 202. And so obviously the block hash associated with that transaction will also change, and we should be able to observe the effect of that in the wallet. Okay, so what I'll show you now is if you go to the Electrum SV SDK source code, which is available on GitHub, I've included some example scripts of how to generate reorg blocks. So you go to contrib and reorg, and so the first script, basically you can use the SDK as a library in Python. You don't have to only use it as a command line tool. So you have full control. You've got your start, stop, and reset command, and some other utility functions. So what we're doing here is starting 2 node instances with a unique identifier node 1 and node 2. And the first thing we do is to generate 200 blocks on node 1, and node 2 is insulated from node 1. So you can add them as pairs of one another, and in which case they would synchronize. But we're not doing that here because we want to create a fork. So we manually submit the same blocks to node 2, and then we create a pay-to-pubkey hash transaction to the first deterministic address, receive address of the wallet with 100 bitcoins. And we save the raw transaction for later and generate a block. So at this point, we have node 1 at block height 201 with the raw transaction with the transaction at height 201, and node 2 is still at block height 200. So now we generate an empty block on node 2 and add the raw transaction to block height 202. So I'll run that just to show you that it works. Okay, so now we have node 1 blocks. Each new line is a new block, and node 2 blocks. And we can now use this script to submit this to the node while the wallet is running. Okay, so in order for this to work with the Electrum BSV wallet, we need to have a hard-coded deterministic seed so that the receive address is the same every time we run the test. So that's a feature of the SDK, which is kind of tailor-made to our own needs. So you just run this command, reset it with the deterministic seed, and it will generate a wallet with the same seed every time. And so now we can start our components. Okay, so we have a blank wallet. So now if we come over to here, we can run the script to submit the first set of blocks. So we can see it's in block height 201, and if we want to, we can start up a what's on chain instance. See that our transaction is there. Okay, and next thing we can do is submit the second batch, which will reorg the first batch. So now if we have a look, same transaction ID, but it's at block height 202, and we're checking what's on chain, and now the block height of 202, and there's our transaction. So as you can see, reorg testing is quite labor intensive at the moment, and you do need to roll your own scripts. But as long as you know the RPC ports the node instances are running on, there's no reason that you can't do all of this in any other programming language. You used to HTTP RPC calls, and you could interact with the SDK via the command line. And there's no reason why you couldn't automate that. So it's doable, but if there's interest for it, I would be quite open to baking reorg handling or reorg simulation into the SDK and making that more accessible, because I think it's a pretty important use case. So the other use case is benchmarking, and I think the main advantage with the Regtest environment is that you can run the same test under the same conditions, and while you're doing that, you can run fine-grained checks for correctness. Doesn't matter how fast your code is if it's not correct. And the other aspect is that depending on how you look at it, removing network latency effects and packet loss and fluctuations in third-party service providers, that might be an advantage or a disadvantage. But personally, I think it's an advantage. And what can also be useful is having the contrast between the two. So if you're finding that everything works perfectly in a Regtest setting, then probably your code is correct, probably. And then if everything falls to pieces on the public test network, you're going to have a much more limited set of issues to go hunting for now, given that you know everything works fine in a Regtest environment. And I actually have experience where I was having issues with packet loss, but only under heavy load. And it was incredibly difficult to debug. And it was only when I contrasted the two where I could show that it was definitely working on Regtest fine. And but on the public test network, I was having these issues. That was the thing that allowed me to find the issue. And as soon as I set up a VPN, everything started working correctly. So maybe that's a rare example, but that's been my experience. I want to throw in a bit of a disclaimer here about the SDK. And that is to say that the primary objective with the SDK was to support electronic speed development. But with that said, it's a generic tool, and there's no reason why it can't be just as useful for any other kind of Bitcoin development. And so because of that, Roger and I thought we really ought to put in a bit of extra effort and make it more accessible. There are still a few limitations. So the main one is that the installation process isn't as streamlined as we'd like it to be. In an ideal world, it would be a one-click installation, but at the moment, depending on what platform you're on, there might be a few additional system dependencies that you'll need to install, things like Postgres, for example, or Node.js if you want to run the What's on Chain Explorer. So there's that, and we currently use the system installation of Python, and that does help streamline the installation process a little bit, but it adds some level of risk that we could have dependency conflict issues down the road. So that's we have a solution for that, which I'll talk about next. But yeah, and the other thing is a general Regtest thing. So if you are reliant on a closed source service or API, then that might be a deal breaker for you, because you need to run that service locally to do end-to-end Regtest testing. So I think the SDK has a lot of potential, and recently there was this tweet from George saying that Ethereum has these great dev tools like this one called Ganache, and is wondering if there's anything similar on BSV, and currently the answer is no, unfortunately. But this was a recent source of inspiration, and so if you go to the Ganache website, what you see is basically it's a one-click installation process, and so they have these bundled installers for each platform. I think they've done a really good job with it, because that's not an easy thing to get right. So they've got a bundled Postgres instance and Node.js and all the dependencies and a few other things. And so what you get is out of the box this browser-based GUI and a local node instance that you can manipulate, and you have everything you need for local development and testing. And so it's an open source project, and Roger and I had a look at it, and we think we could probably use a lot of what they've already done to get a head start on something similar. So, so that's a definite possibility. Yeah, so if we went this route, obviously we'd be able to bundle all of the things that are needed into a one-click installation process, so namely things like Postgres and Node.js and Python. And just going back to what I was saying earlier, we'd be able to also avoid using a system installation of Python. We'd better embed our own instance of Python and have all of the various libraries and dependencies bundled. So it's definitely something that we are open to as a possibility. So wrapping up, it's a bit of an upfront investment to set up a Regtest environment, but I think it pays dividends, and you're going to be rewarded with a faster iteration cycle. You're going to have more confidence in the end product. You're going to be able to test your application in ways that just aren't possible on a public test network, namely things like Reorg handling, and it's great for benchmarking. And I think the BSV ecosystem's crying out for something like this. And I'm not trying to claim that the SDK is the perfect solution, but I think it's a start. And I think if we had something like a Ganache, a one-click installation process and a nice polished GUI, I think that would be getting closer to the mark. And I think that would be something that would be very valuable. So that's about it.